All right, I think we can go ahead and get started. Yes? Awesome. Hi, everyone. I'm Matt Connor, one of the product managers at Anyscale, and really looking forward to this session. Yesterday, Jan showed this slide where he talked about how simple things should be simple, and we introduced and spent some time talking about Anyscale endpoints. He also talked about how complex things should be possible, and he alluded to the Anyscale platform making that possible. What's really exciting to me about today in this session is that we're going to dig in and show you how the Anyscale platform can make complex things possible, and that's largely because of workspaces. Workspaces are a huge part of how we've made it for everyone able to run their array workloads in production with Anyscale. Just real quick overview, we're going to talk about workspaces, the motivation behind them, what problems we solve with workspaces, do a walkthrough and a demo, and then also want to make it as interactive a session as possible. So feel free, capture those questions you have. We'll pause at a couple various points to take questions, but we really do want you to make sure you get a lot out of this session. So with that, I'll hand it over to Sofian, one of the engineers at Anyscale.
Yeah, thank you, Matt. So we'll start with basically a little bit of background about how we ended up developing workspaces. So the intention and one of maybe the success reasons behind Ray is that the UX is pretty simple, right? So when you're a new developer and you're trying to learn Ray, the very first thing that you learn is how to parallelize some code where with the concept of tasks mapping directly into methods or functions, and the similar thing for actors mapping directly to classes. And that simplicity that is built into Ray allowed it to be very popular, because the entire promise behind Ray was to make it easy for you to parallelize code. Anyscale's mission, I wasn't here from the beginning, but at least I was told, it was all about building the infinite laptop. And that mission is sort of a continuation for the one that Ray started, which is to do something that is very simple, to make it very simple for people to write code on their laptop, and then when they need to move their code into production, it's also a simple transition, similar to the Ray promise of keeping the abstractions easy to understand. And so develop on your laptop and deploy to production when you're ready to run at scale. And obviously, starting to work with customers, we noticed that actually that paradigm doesn't work exactly that way. So sure, you'll start on your laptop, you'll develop, test, and debug. But then what we found out is that most of the customers, before actually going to production, they end up having to do some testing in a production or production-like environment. You can call it staging, call it pre-deploy, but it's definitely outside the realm of your laptop. And then they would end up having to, after repeated this iteration a few times, they would have to do the deploy. And to state the obvious here is like this type of development process is really expensive because it's a longer iteration cycle. So just imagine every time you're debugging a piece of code, you actually have to go and deploy and wait for your code to reach a remote machine, and then you wait for the job to finish, and then you read the result, and then you come up with another theory, you try it again. If you do this, obviously this becomes very, very expensive. And the reason a lot of customers needed to do that is most of the time fundamental reasons, right? So think of the simple ones. Right now with LLMs, we can give easy examples because most of the time the actual required hardware that you need to run those LLMs on is not something that we have on our laptops. But even before that, just imagine you have a simple Python code, and I use an M1 for development, and I need to go and run it in a Linux environment. The dependencies won't be the same. So when I install my dependencies, I actually need to run against different set of dependencies. And if something changes, eventually it's going to break. So whatever works for you locally might not work for your machine. And obviously, once you start scaling, then you need to leave the realm of your laptop. So the whole premise of workspaces is to bring back the original vision of Anyscale and bring back the simplicity. Make it easy for people to develop in an environment that looks exactly like their laptop, and then being able to debug and iterate really fast in that environment. And then when they're ready, they can go into production pretty simply. And some of the main principles behind that is that we want to be able to give you give our customers a zero setup experience, the ability to not just have a dev machine in the cloud. I'm sure a lot of us here have dev boxes in the cloud, but really give you a dev cluster, a cluster that is capable of scaling. And hopefully that experience that now your development environment runs on a hardware and a configuration that looks very, very similar to the one that you run in production means less surprises, means things are less likely to break. But all of this meant that we needed to provide an experience where you can develop in the cloud that actually is as good as developing locally. So for that, the main pillars of that experience is we wanted to give integration with the favorite tools. So with Workspaces today, we have integrations with VS Code and Jupyter, as well as integration with Git. We think of Git as sort of a main pillar in the development environment. And one simple example is just imagine that you start a workspace and you start developing. You don't want to kind of reset up every time your good credentials every time you start a new workspace. Also now with the age of LLM, it's very important to have the ability to serve, right, applications. So if you're running in a remote environment and you can't be able to inspect those applications, that's going to be an issue as well. But also once the development process is complete and once you're ready to actually move your workloads into production, we need to have a very simple path for that, as well as the ability to share, duplicate, and allow the ability to share with your teammates. So let's imagine that you have an environment where you perhaps hit an issue and you need to make it easy for somebody else to come in and debug right where you left. You can actually duplicate that workspace, hand it over, and they can take it. So the intention of this session is really make it interactive and spend as much time in the code and in the environment. And I see a lot of people from Anyscale here, but just as a show of hand, how many of you have not used Anyscale before? All right, good amount. That's good. How many of you have used Ray before? OK, cool. So the good thing is this overview is meant to be covering a wide range of concepts in Anyscale. We're actually not planning to dive very deep in any of those. So it'll be a very nice introduction in terms of what is the Anyscale platform and how we think of the main concepts. So I'm going to start here with the workspace-centric view into the world, and then Matt is going to take a step back and walk us into what other environments. So what you're looking at here is the Anyscale console. And one of the popular entry points for the Anyscale console is a concept that is based on workspaces that we call it applications. So it's also known as workspace templates. It's basically packages of applications that are ready for you to start to play with. So here are some examples. There are batch inference. There's LLM serving. There's fine-tuning. So you can find whatever workload you're actually planning to do, you will find an example with a starter code that can get you started. So if I were to start this introduction to Ray in Anyscale, first thing I need to do is select a cloud environment. And a cloud environment is just really an isolation of resource. So the way we think of clouds in Anyscale is every time you bring your own cloud, whether it's an AWS or GCP, basically you can have multiple of those isolated environments for development, for production, for staging. So what we landed in here is the workspace homepage. And with workspaces, think of it, there's few concepts that come in hand to hand. So the first one is the cluster environment. And those are, think of them as Docker images. So every time you start a machine, it has to have an image on it. This is the cluster environment. And Anyscale comes in with plenty of cluster environments that are pre-built for you that will include a variation of Python versions, Ray versions, as well as GPU and CUDA versions. It also comes in with a Docker build environment where you can build your own Docker and you can build your own images. So that makes it really easy to set up your environment and jump into it and be ready to start coding. It also comes in with the concept of what we call compute configuration. Think of it as the compute parameters of your cluster. So if you're familiar with Ray, this is going to be very similar. Your head node would have a type. You can define multiple worker nodes. Each of those worker nodes will have a type. Obviously, the type of those nodes will match those in your cloud provider. So now that I'm back in this workspace, it's just basically trying to introduce me to basic concepts in Ray and in Anyscale. You can see I have a bunch of buttons here, one for a Jupyter Notebook. I have one for VS Code, and I have one for the Ray dashboard. So with this, with zero setup, I don't have to do anything. All of these environments is pre-set up for me, is ready for me to start coding. So I can jump right in, get to the editor. Like, for example, for VS Code, we have a bunch of extensions that are pre-built and ready for you, so you can even run a code and start debugging. But obviously, a lot of us like their local environments, and we might want to be able to develop locally. We also come in with the ability to connect with your local version of VS Code. So if you click on this, you will have a local VS Code started, pre-set up for you. You have a connection to the remote machine. Your extensions are still there. Your theme, your environment is set up the same way. And this is while it looks local, it's still a remote environment, right? So if I am on the left side, I'm in a hosted version of VS Code. And if I were to type anything, then this will show up on the right side, right? So it have the perception of being remote, but it's also perception of being local, but it's also remote. So what we're going to try to do here together today is actually try to build an LLM application end-to-end during this talk and while covering all of the concepts of Anyscale. And the hello world of the LLM application these days is RAG applications, right? And there's this really cool blog post that Jerry from Llama Index and one of our own, Amog, has wrote about the power of using Llama Index and Ray data together that I'm actually going to be stealing in order to show us the demo here. But what this blog post is walking us is the ability to use Ray data with Llama Index to process a large amount of data. And what we're going to be doing here is building a website called Ask Me Anything. So we're going to go find one or two websites that we want to index, run a bunch of logic against those websites to embed them, and then build a serve application. And that serve application will offer me an Ask Me Anything UI that we can actually type anything in a Google-like form and get an answer from the websites that we embedded. So the very first thing that starts there is downloading the data. And you can look at the blog post, but the download the data logic is actually pretty simple. It's just a wget command. You run, and it's going to go and scroll. It's going to go and go through the website and download it. I had that data downloaded for us already. So let me start the embedding logic, which basically is just going to go crawl through all the files that were downloaded and start the embedding process of those files. So I'm just going to run the embed all method here. And this one started the Ray cluster for me. And it's realizing that I actually need more resources. So it's going to start adding more nodes as we speak here. So I'm just going to take a look at the Ray dashboard so we can sort of take a look at the before state of the cluster. So what we're looking at here is we're looking at a one healthy node. And we're going to start seeing some, under the pending, we're going to start seeing some GPUs coming up here because all the embedding logic that we're trying to embed is actually GPU intensive. But let's take a look at the data. And speaking of data, I want to walk you through some of the data choices that we have with workspaces. Given that it's not a development environment in an isolated machine, it's actually a dev cluster, you want shared storage. And we offer different types of shared storage. The very first one is NFS-based, so it's network file system. So if I were to go to my files here, I have my head node storage, which is, think of this as the storage that persists every time you turn off your workspace and you turn it on again, right? So it's sort of like your local environment. But I also have other type of storage, like a cluster storage. This is NFS shares that are shared between all of the nodes that are running within the same cluster. User storage between all of my clusters. So I actually stored the information that I'm running, which is I'm actually embedding both the Anyscale blogs and the Ray documentation. So you can see in this folder, this is the actual data that I'm actually embedding right now. And the reason it is important to call out that it's running in an NFS storage is because as my cluster is scaling, it needs to use URLs that all of the nodes across my cluster be able to access. We also offer object storage. So if you're in an AWS or a Google account, you can use S3 or Google Storage in a similar manner, where you can use an environment variable that will be the same environment variable across all of your cluster, and it would give you a similar experience. So let's take a look at how our embedding logic here is going, and it looks like we are launching some instances, and it's starting to go here. So this is the part of the demo that is a little bit risky, because we don't know if we're going to get those GPUs or not. But I'm an optimistic person in life, and this is where I hand it to Matt so he can talk to us a little bit more about the Anyscale platform and some of the concepts that is around workspaces.
Cool. Thank you, Sofian. So we obviously just spent quite a bit of time on workspaces, but there's a whole lot more to the Anyscale platform. And what I thought I would do is spend a couple minutes unpacking all of those different concepts and how they fit together. You can see here our team put together a nice graphic of all of the things that exist within the Anyscale platform. And really, there's a few very important concepts that we've built in to Anyscale. The first that we talked quite a bit about yesterday was endpoints. Now, what's interesting about endpoints, and you all have heard it over the past couple days, is the API-like experience to use your LLMs. But the interesting thing to me about endpoints is it's actually all built on the Anyscale platform with our underlying concepts and capabilities. So we put it at the top of the stack because what we've done is provide another abstraction, and that's really what we've accomplished with endpoints. We also have templates. Sofian talked about templates. Great way to get started with a very relevant workload for your use case, and then immediately jump in and be ready to move to production. And then we have jobs. I saw a lot of folks raise their hands. I don't know if you guys have all used Ray jobs. You can think of jobs very similar within Anyscale. We have Anyscale jobs to help you run those in production. We'll talk a little bit about some of the differences there in a second. And then Anyscale services, which are how you run your Ray serve application in production. And then workspaces, and all the way down at the base layer, that cluster environment or images that Sofian showed, and the compute configuration. Now, talking about Anyscale services for a second, this is how you go about running your Ray serve application to do something like online model inference in production. It provides out-of-the-box fault tolerance and high availability, the ability to do zero downtime upgrades. So you may have seen during the presentation yesterday, we talked about that with private endpoints. The reason we're able to do that with private endpoints is because of Anyscale services. There's built-in monitoring and tracking via the Ray dashboard and Grafana dashboards, integrations so you can send logs to something like CloudWatch if you need, and it also supports multi-availability zone deployments. Talking about Anyscale jobs. Anyscale jobs, like I said, for those of you who have used Ray jobs, very similar. They automatically can come pre-configured to retry if there's something that happens. They'll actually start a cluster, run your job, and then terminate the cluster. So the full lifecycle management of your cluster and resources. Jobs run on dedicated resources, which can be really important if you're doing something and a production job that you really want to make sure it completes. There's no competing resources. They have built-in alerting and monitoring, and obviously they run in your cloud with your data, so very private and secure. And then at that base layer, Sofian talked about it, the compute templates and cluster environments to define the shape of your cluster and the dependencies that you want to include. So that's kind of a brief overview. You may have seen in the console that each of those concepts is exposed in the left-hand navigation. And what we've really done, and what's really exciting to me about workspaces, is that it is the absolute glue that connects the underlying infrastructure to making it possible for you to run in production. And so what Sofian will jump in and show again here in a second is how you can actually go from what he did in a workspace and now run that in production as a job or an Anyscale production service. Cool.
Sounds good. So, it's moment of truth. Who thinks here that we actually completed the embedding job? I just want to see the face. All right, got like a few people. Most of them work for Anyscale. that tells you something, right? Like we have high hopes. So it looks like we got a bunch of nodes going on here. So let's take a look and see where we are at the embedding job. Looks like the embedding is going. So that's actually pretty good. We're about running at 6 minutes. So we're still attempting to launch some instances here, and this is sort of expected part of the demo, where it all depends on how much resources we can get. So obviously, I've done this before, and one of the ways that we can actually I've done this embedding before, and the next part of this demo is to show you how we can take this embedding job and also run it in production job as the Anyscale jobs. So think of it if you're building a real-world application. You actually don't want to be running all of this code from a single place. Say you have an Ask Me Anything website that is running on a Reddit website, or that is running on Twitter. You probably want to run this job multiple times a day, right? So how do we go from the embedding logic that is currently running into an Anyscale job? We actually have to just submit this one command here. And with this command, we'll take the code that we have in our Anyscale workspace. We'll take the environment that we're running inside of that Anyscale workspace, and it will kick a new job for us. And a job in an Anyscale concept, if you wish, is basically a managed application. We're going to start a whole new cluster for you. We're going to take your code, run it inside that cluster, and then the result of this job is an index in a vector database that will be stored in a location where, if we want to use it in other places, say a service, you can actually use it in there as well. So in this case, you can see that I actually got a bunch of job submissions submitted from this workspace, and this latest job that I just submitted is actually awaiting the cluster. So while my other job is still running and is still embedding, I'm also going to run the next part of this, which is the deploy part. And this is because I already kicked off the embedding part before, so I already have the embedding index running. What this deploy part is doing is running an Anyscale, or is running a RayServe application inside of my workspace environment. So all of this is happening really within the context of my workspace environment. So I started with a single node. I was able to run the entire embedding process within it. And then I'm moving on right now to run the process of serving that embedding from within my workspace. So let's go take a look at what's going on with the Ray dashboard. So I can see that my serve application is kicking off here, and it's actually deploying. And the minute the serve application is ready for use, I can go back to my website here, and I can find out that I have this Ask Me Anything port. So what is ports? So again, we talked about the ability to develop in a browser and the ability to develop remotely. So if I'm running an application that I need to test, like in this case, and I run a web application or a front end for my application that I need to interact with, I need a way to interact with it. And ports is another example of how workspaces make this easy for you. So now I have this website that is served right from my workspace, where I can come in and ask it, what is RayServe? And I'm choosing the blogs. The blogs is the Anyscale website, and the docs is the Ray documentation. And if I click Ask, and hopefully with a little bit of help, if things are working, things are not working. What we should have seen here is we should have seen the answer coming in through, and maybe because the embedding is not working yet. But that's pretty much what we wanted to walk through the entire process from starting from the embedding job here all the way to the serving part. So at this part here, it would be good to open it up for questions, see if you guys have any questions while I run the other deploy.
Question was if there's any quota or cost management in the workspace. One of the things you can do when you define that compute configuration and launch your workspace is actually set idle termination and max uptime. So if you want the cluster to turn off after a period of 20 minutes of inactivity, it'll do that. You can also actually specifically say, I want to terminate this cluster in 2 hours. Maybe Sofyan and I know that this demo is going to be a half hour, and we're both going to be running around after. We can make sure that it'll turn off no matter what in an hour.
And that's probably that's one very common way people use workspaces, is they always set idle termination, because as long as you're actually using it, if you're writing code, if you're running workloads, if you're doing anything within it, the workspace will not terminate. So it will act really like a machine that you don't have to pay for. Because when it terminates and you come back into it and then you start it again, then your environment is going to be ready for you to develop.
Any other questions in the back?
I guess an extension of the same question in some ways is when you are, if I have a job demonstration of, say, clusters of really small instances, once it gets preempted, does the job continue on its own, get the on-demand sensitive, how does it work? Or will it stop because
Yeah, the questions about preemption and how that's handled. One of the things you can define in that compute configuration is the scaling behavior. So if you want to do spot and fall back to on-demand. So within Anyscale, as you run your job, we talked about gracefully handling eviction and being able to fall back to on-demand instances to make sure the job will keep running.
So just back to the demo. So now that the actual embedding job finished, the website is now responding. So when I say, what is Ray data, and I click ask, I responded the last time. All right. Well, I responded the last time.
We saw it happen.
Cool. Any other questions? Sweet. We can give you back 3 minutes back. Oh, we have one more.
One more. Yeah, good question. How does pricing work? Pricing, it's a consumption-based model. So as you're actually using resources, you're charged for while those resources are running. And feel free to follow up with us, and we can talk to you and our sales team about what that exactly looks like. Cool. Well, if there's no other questions, thank you all. We think workspaces are a really powerful tool to help you build Ray applications, and hopefully we'll see a whole bunch more of you who haven't had a chance to use them yet do so soon. Thank you.
Thank you.